Assalamu alaikum wa rahmatullah. Today in this class we are going to learn about a new concept, which is the link aggregation. Objective of this class actually is to explain the use of link aggregation in the enterprise network. So we will learn why we need to use the to implement the link aggregation. What is the possible scenarios, and also to describe the various forms of link aggregation supported. Here we will learn what are the types of link aggregation and when we need to use each type. Also, we will learn how to configure link aggregation solutions. This topic also is very simple, and it may take about 20 to 25 minutes, inshallah. So actually, link aggregation is used to provide an improved quality of links. So sometimes if let's say we have this topology, the network admin should monitor and should evaluate the performance of this network. So after the evaluation and monitoring, they will find bottlenecks. For example, if let's say they find this link makes a bottleneck, for example, so in this case, they have to make a link aggregation to increase the bandwidth. Also, link aggregation is used to provide what they call it the backup link. So in case of failure, then backup links will be ready to work to take over the original link. So in general, there are two scenarios of using the link aggregation. The first scenario is to increase the bandwidth. Second scenario is to enhance the reliability. The other scenario is to support load balancing. So if let's say load balancing, actually there are many scenarios. If let's say we want to create two connections to internet for UPM campus, and these two connections to internet are using different technology. So for example, one of them is over TM fiber maybe, and the other one is over satellite. And we want to use both of these sources at the same time. So in this case, we have to enable them in the load balancing mode in order to be used at the same time. So traffic will be forwarded alternatively among these two internet sources. Okay, let us take this scenario first. See this scenario. So in here, if let's say we want to connect these two switches using 3 links. So at the beginning, we have to create an Ethernet trunk. So this is the first thing. We have to create the Ethernet trunk here at the switch A and also at the switch B. Then we have to go to every interface that we need to attach to that Ethernet trunk, and we attach it to the Ethernet trunk in both sides. Okay, later we will learn how to do this configuration. In general, as I mentioned, link aggregation is used to increase bandwidth or to enhance reliability. Reliability can be enhanced when we make a backup link for an original link. So in case of the original link has failure, then the backup link will take over and will work based on that. Okay, application in the enterprise network. Application is made at critical points to enhance throughput. So in this scenario, the first application is to enhance the throughput. So for example, if let's say here we have a bottleneck, then we have to increase the speed of this link between the switch A and switch B by attaching multiple networks, multiple links to the Ethernet trunk. So let us see what is the comments here. Maybe there's something important here. So I don't know why this doesn't work, but anyway, doesn't. I want to enlarge the font, but it doesn't work. Anyway, link aggregation is often applied in areas of the enterprise network where the high-speed connectivity and the potential for congestion is likely to occur. So in case we have a congestion here at this bottleneck, then we need to increase the speed by using link aggregation. This generally equates to the core network where responsibility for high-speed switching resides and where traffic from all parts of the enterprise network generally generates or congregates before being forwards to destination either in other parts of the network or remote destinations beyond the boundaries of the enterprise network. So the example demonstrates how core switches, SWA and SWP support link aggregation over number of links that interconnect the two core switches together as a mean of ensuring that congestion does not build at a critical point in the network. So here they use this link aggregation to ensure that there will be no congestion at this point. Okay, link aggregation modes, we have manual mode and we have LACP. LACP mode and manual mode. In manual mode, all links load balance and are forwarded. So for the manual mode, all links are active and will be enabled, and I mean the load balancing will be enabled, and also their mode is forwarding. All of them will be in the forwarding state. In the LACP mode, so in this case, for this example here, the solid line is active and the dashed line is backup. So in this case, the solid lines only will be active and their states will be forwarding, and the dashed line will be inactive and it will be used as a backup. So in case of failure here of any of these solid lines, this dashed line will take over and will start to be active to replace the valid link. So this is two modes. Later we will learn how to configure them. Depends on actually the use of manual mode or LACP mode is depends on what scenario you have and what application you want to configure this application for. Okay, so here there are some comments here also we have to go through. I think we have to go through. So maybe this one, link aggregation supports two modes of implementations, load balancing mode and static LACP mode. Okay, if I'm not mistaken, there's only one important comment here we have to take into account. Actually, in order to do link aggregation, all links must be from the same type. So if let's say the first line is 1 gigabit per second, the second should be 1 gigabit per second, and the third also should be 1 gigabit per second. We cannot combine links that have different speeds or different features or different properties. Okay, so all aggregated ports have to be from the same type. And here we have, in this slide, we have the data flow control. Actually, data flow control is used to control the flow inside the or through the Ethernet trunk. So for example, if let's say the 3 links are in the load balancing mode, so the data flow control will control how much data should be injected in the first link and how much data should be injected in the second link. So it will be controlling all the traffic forwarding inside or through the Ethernet trunk. Data flow sequence must be maintained over number links. Okay, because we have multiple links here used, multiple physical links to form one logical aggregated link. So in here, because of this, data could arrive at the destination in wrong sequence. So maybe bucket 100 arrived before bucket 80. So data flow control should be responsible to reorder the packets and to put them in the correct sequence. So consistency of physical member interfaces must be maintained also. So the data flow control should maintain the consistency of the physical interfaces that are members of the Ethernet trunk. Okay. Here, to prevent the disorder of frames, frame forwarding mechanism is used to ensure that frames in the same data flow reach the destination in the correct sequence. So this is all about the bucket reordering. Then this mechanism differentiates data flows based on their MAC addresses or IP addresses. Okay, the data will be differentiated based on the destination MAC address or the IP address. In this manner, frames belonging to the same data flow are transmitted over the same physical link. After the frame forwarding mechanism is used, frames are transmitted based on the following rules here. Frames with the same source MAC address are transmitted over the same physical link. This is only to avoid the disorder of packets or the wrong order of packets. So data or frames belongs to the same MAC address will be transmitted over the same physical link. So if let's say we have 3 physical links forming one Ethernet trunk, then if let's say BCA sends to BCC through this Ethernet trunk, then this data will use only one physical link. For example, the below link here, or maybe the top link here, it depends on the data flow control algorithm. The other thing, frames with the same destination MAC address are transmitted over the same physical link as well. So if the destination MAC address or the source MAC address are the same, then the transmission will be over the same physical link. Also, frames with the same source IP address are transmitted over the same physical link. Frames with the same destination IP address transmitted over the same physical link. And also frames with the same source and destination MAC address are transmitted over the same physical link. And at last, the frames with the same source and destination IP address are transmitted over the same physical link. So this is the rules that's used by the data flow control to avoid the misordering of data. Then here, now we learned that the link aggregation mode have 2 types, manual mode and LACB mode. And also here, we have 2 types in general of link aggregation. So the first type is layer 2 link aggregation, which could be used between switches. And also we have layer 3 link aggregation. L2 and L3 link aggregation, both of them can use either of these 2 types. layer 2 and layer 3 can be manual mode and or LACB mode. So it depends on exactly what you want to use or what you want to implement. So for link to aggregation configuration, in order to configure the link aggregation between two switches, similar to what we have here in this slide, the first thing you have to go to switch A. You have to create the interface Ethernet trunk 1. So you have to use this command to create the Ethernet trunk 1. Then after that, you have to go to the interface, first interface here. Then you attach it to the Ethernet trunk 1 that you have created here. Then after we attach the first interface, we go to the second interface and we attach it to the same Ethernet trunk. If we have a third interface, we need also to attach it. We have to go to the interface, the third interface, then we attach it to the Ethernet trunk again. And in this case, we finished only the left side of the switch A. And also we have to go to switch B, and we have to do the same thing. We have to first create the interface of Ethernet trunk 1, then we have to go to first link, second link, and third link, and we attach them all to the Ethernet trunk 1. So the only condition that we have to keep in mind, all links must be from the same type, they have same speed, and everything is the same. And also, the ports at the both sides supposed to be the same. Also, if we enable automatic mode here at the switch A, we have to enable the automatic mode at the switch B. Or if we use the LACB at the switch B, also we have to use LACB at the switch A. So everything should be compatible between the two switches. So link aggregation requires the binding of the physical member interfaces to the Ethernet trunk. So this is how to bind the interface. This one, this interface gigabit Ethernet 001, we bind it to the Ethernet trunk 1 by this command. Okay. For layer 3, we have only two extra steps we have to do. Two extra steps we have to do. So here, at first, we create, at the layer 2, we create the Ethernet trunk 1. Also here, we create the Ethernet trunk 1. But here we have to undo the port switch. We have to undo port switch. Then after that, we have to assign an IP address to the Ethernet trunk itself, this side. So we, by this command, these two physical links will use the same IP address. Okay, so both of them will form a virtual link or logical link that's going to use this IP address. After this, we have to go to each interface involved in this Ethernet trunk, and we have to bind it to the Ethernet trunk using the same command. So only we have this two commands different than the layer 2. This is the only difference between layer 2 and layer 3. This one, undo port switch, because port switch is enabled by default to support the layer 2 link aggregation. But if you want to support the layer 3 link aggregation, in this case, you have to undo the port switch, then you have to assign the IP address. Here, using this command, display interface Ethernet trunk 1, you can see the status of the Ethernet trunk and also its members. So here, Ethernet trunk 1 current state is up, line protocol current state is up, and also gigabit Ethernet 001 is up, and gigabit Ethernet 002 is up, and the weight of both members are the same. So in this case, they will work in the load balancing mode. Here we can see the number of ports in trunk 2, 2 members. and the number of ports in trunk also, the up ports are also 2. So here we didn't have any issue. At last, we have the summary here. Summary has 2 questions. The first question is, if an administrator attempts to add a gigabit Ethernet and fast Ethernet interface to the same Ethernet trunk interface, what will occur? So a fast Ethernet interface and gigabit Ethernet interface cannot be added to the same Ethernet trunk interface. Any attempt to establish member links of different types will result in an error specifying that the trunk has added a member of another port type. So that's why I always mention that the involved or the members of an Ethernet trunk must be from the same type, must have the same speed, and they must support the same technology and the same versions of protocols. It should be noted that the switch S5700 or the series of S5700 switches support gigabit Ethernet interfaces only. However, this behavior can be applied to other models, including the S3700 switch. So only the LACB mode is capable of supporting backup member links and therefore should be used if backup links are required. So if you want to apply or to implement the backup links, you have to use the LACB. So we forgot to read the question. In order to establish backup member links, which mode of link aggregation should be used? So in this case, we have to use LACB mode to enable the backup link. And the link with higher priority will be active, and the other link with lower priority will be inactive. That's all about the link aggregation. I hope that you understand. If everything is okay, that's fine. Otherwise, you WhatsApp me in case of any unclear things. Thank you, and see you, inshallah, in the next class. Assalamu alaikum.